and welcome to the session. My name is Brett Looney and I'm a Global Solutions Architect based in Perth, Western Australia. With me today is Mitch Beaumont, a Principal Solutions Architect based in Sydney, New South Wales. Today, we're going to talk about extending the power of AWS using hybrid cloud services. So let's get to it. First, I'd like to talk about what we mean when we talk about hybrid. What we're seeing is that the term and the solutions are being reinvented very quickly. So what is it? Typically, customers see it as a mix of modes. Early on, it was defined as a combination of cloud alongside on-premises data centers, but this led to a debate about what looks like a binary solution. Should customers operate only in the cloud or only on-premises? As AWS, we started with digital native customers who were all in on the cloud. And while we encourage customers to go all in, this doesn't work for everyone, particularly large enterprises with existing on-premises footprint, both hardware and software. In response to this, we spent a lot of time building cloud-specific pieces with sensible bridges back to on-premises data centers. What we found was customers were using these services, such as Storage Gateway or Direct Connect, in combination with other third-party technologies that promised hybrid capabilities, but never really lived up to that promise. So we were watching this and listening to our customers, and we did what Amazon does, go back to first principles. It turns out there are a lot of different reasons for customers to want hybrid solutions. I deal a lot with mining customers, so let's consider what they need because it covers a lot of the different use cases. In this case, our prototypical mining customer does a lot of exploration. So they need to have a way to collect data and do some level of processing on the data while completely disconnected from the outside world. Second, they have mine sites with data centers. These need to run process control systems, safety systems, scheduling systems, or analysis systems, IoT components, you get the idea. These need to be local to the mine site for latency reasons and continue to run in the event of a network failure between the mine site and the rest of the world, but they're generally connected all the time. Third, they have data centers in major cities, which they eventually want to exit from. In this case, it's a migration process. Run the existing workloads until they can be shifted, either lift and shift or through application modernization into the cloud. So let's look at the first use case for our mining company, which is totally disconnected work. Exploration on land or at sea. For this, we have the Snow family of devices. The original Snowball device was built to perform mass data migration, but since then, the family has expanded to also perform edge compute and storage. The intention of all the devices in this family is to run at the edge, provide storage for data collection or migration, and to provide a modest amount of compute power so that data can be processed, compressed, or summarized as required. You can also run machine learning inferencing on the data if you need to. Last year, we announced Snowcone as the newest member of the family. It's a completely portable edge compute device that you could carry in a backpack with an external battery if you had to. It can be used completely independently of the AWS region, disconnected from any network. If it is connected to a network, the onboard compute can communicate with both the local storage and the region, but it can also operate autonomously. For reference, a Snowcone is about the size of a large hardback book. I checked, and it's roughly the same size as my CCIE Routing TCP/IP Volume 1 book, Network Nerd Life. There you go. For much larger data transfers and where you need significantly more compute resources, the Snowball Edge has got you covered. But you won't be carrying it around in a backpack at almost 25 kilos and certainly not powering it by battery. It's about the size of a small suitcase. You can cluster Snowball Edges together, up to 10 in a cluster for large-scale storage and compute support. Note that the original Snowball with no compute is now retired and you should only order the Snowball Edge. Both Snowcone and Snowball Edge provide encryption at rest. When you are using them to transfer data to AWS, we securely wipe them once the data has been copied to S3. This table shows a comparison between the various Snowball and Snowcone devices. The only thing I'd add here is that while you can connect the Snowball Edge at 1 gigabit a second, if you're transferring large amounts of data, you will definitely want to connect at 10 gigabit or higher to cut down on the transfer time. But if the data is being trickled in, that is, you're not doing bulk data transfer, then 1 gigabit a second is totally fine. The Snowball Edge and Snowcone devices are not designed for long-term installation on a site. Generally, you wouldn't keep them for more than a year, and in most circumstances, particularly when you're migrating data, that time would be much shorter. But our mining company needs a permanent installation of their infrastructure on their mine site and in their data centre. And the capacity of those installations exceeds what can be provided with a Snowball Edge cluster. That's where Outposts comes in. What we've heard from customers is two things. First, that they want the same experience for running their applications at the edge on their premises that they get in AWS. They want a consistent set of APIs so that they can use the same tools to create, operate and maintain applications regardless of where they are deployed. In an ideal world, that means you can create an entire workload which uses compute and storage in specific ways and then deploy it either in the cloud or at the edge without making any changes. Second, customers don't want to be managing infrastructure. They want to get out of that 3 to 5 year update cycle for compute and storage, and they want to spend less time and effort patching firmware, upgrading hardware, taking care of maintenance contracts and having to deal with those niggling little problems that happen because the infrastructure stack comes from a variety of vendors. Outposts is the answer to that. It's a completely managed hardware solution, managed by AWS on your behalf using the same hardware that we use in the AWS region. At a firmware and a hypervisor level, we patch and upgrade it using the same mechanisms that we use in the region. If you haven't noticed that happening, that's the intention. The same thing happens on Outposts. If components fail, we know, because we monitor the system, and we replace those parts for you. That's all included in the price. All you have to do is provide space, power, cooling, and network connectivity. Then you can just use it. And the best part about it is that it appears in the AWS console just like compute and storage in the AWS region. You can just say, launch this task over there, where there is the Outpost. Our mining customer can use Outposts on their mine site in their data center to replace aging compute and storage hardware. As you can see, capacity isn't an issue. You can have between 1 and 96 racks, and there are a wide range of AWS services available. Because Outpost uses the AWS control plane, the same APIs that are used in the region just work on Outpost. This means that the operations team can take a predefined workload, even a templated one using CloudFormation, and deploy it onto the Outposts on site. This also helps with data center migration. Generally, these take years and still require infrastructure on site that has to be maintained. Here again, our mining customer can use Outposts to do the first part of their migration while not having to maintain any hardware. And then, as they are ready, they move workloads into the region. So what if a whole rack of capacity is too much? For some small sites, that might be the case. Outpost servers is coming in 2021. There will be 1RU and 2RU variants running Linux and Windows with Graviton 2 or Intel CPUs. These will be available sometime in 2021. So great, our mining customer has quite a few options for running compute and storage at the edge, but which one should they choose? Some choices are obvious, others not so much. Here's a handy flowchart. The two biggest differences between the Snow family and Outposts are that Snowball and Snowcone are designed primarily for data migration and local processing of data as it is being ingested. And they can operate completely independently of the AWS region. They don't need network connectivity. Outposts, on the other hand, connects to the AWS control plane, but it can also provide for far greater capacity and many more AWS services. If our customer needs disconnected operations or is doing data migration, then Snowball and Snowcone are the obvious choices. It then becomes a question of storage and compute capacity. One edge case is if our customer needs to set up a temporary site for a few months and needs basic compute and storage services. Here, they could use a Snowball Edge cluster. For a more permanent installation, Outpost is generally the preferred option. It provides large scale or small scale with Outpost servers coming with the same control plane that the AWS region uses. Essentially, and it is really like this, in the AWS console, you simply select the Outpost as the place where you want to launch a workload. This decision tree is very basic and doesn't cover every situation. For example, there are other options such as VMware Cloud on AWS. If you find yourself in a position where you're trying to decide what to do, please contact your nearest AWS solutions architect and we can guide you through this. Two other options of note that you may have heard about. AWS has local zones in a few cities in the US with another 12 coming online in 2021. This is where we place compute and storage infrastructure in a city close to our customers where there isn't already a region. It provides low latency access to AWS services, pretty much the same mix that you would find on Outposts, managed by AWS for our customers. Unlike Outpost, there's no need for you to provide data center space, power or connectivity, as it is all managed by AWS. Wavelength takes this one step further, putting resources at the edge of 5G networks to provide very low latency for mobile applications. Again, this is an AWS managed service in conjunction with mobile network providers, where we place infrastructure in their facilities to provide customers with the ability to process data from mobile applications truly at the edge. Note that local zones and Wavelength are not yet available in Australia. If you're interested in these offerings, please come and talk to us, as you know we take customer feedback for all of our services and we'd love to be able to help out here. So that covers the underlying infrastructure. The Snow family and Outpost provide a consistent way to run workloads in the cloud or on premises. But what about the applications and the workloads themselves? Mitch is now going to talk about using containers to achieve even more consistency for application workloads.
Thank you, Brett. Now, we've heard from Brett how AWS provides companies such as our fictional mining company with a number of different options for running their workloads at the edge. Let's now take a closer look at some of the practical applications of these capabilities. And I often find that one of the best ways to learn is through example. And so, I'm going to build on our fictitious mining company example with a specific use case that involves an architect at that mining company. Now, the architect's name is Sarah. Sarah's under a lot of pressure from her leadership team to modernise their ageing portfolio of applications in order for their business to become nimbler. The CIO has set out a strategic vision for the application modernisation initiative, which centres around the use of containers. Sarah and her company are already using AWS for some simple test and development environments. Sarah looks to set up a meeting with AWS. Now, during Sarah's first meeting with her friendly neighbourhood solutions architect, Sarah asks, how does AWS think about containers and what are the options for running containerised applications on AWS? Now, making AWS the best place for our customers to run their containerised applications has always been our top priority, since way back in 2014 when AWS first introduced its native container orchestration platform, Amazon ECS, or Elastic Container Service. Since then, customers have continually challenged us to innovate on their behalf, and the container landscape has evolved considerably. We now think about that landscape in four broad categories. Firstly, application networking, in which we've got services like AWS Cloud Map, a cloud resource discovery service, and AWS App Mesh, a service mesh that provides application-level networking to make it easy for your services to communicate with each other across multiple types of compute infrastructure. Next, we've got our management services, with services including Amazon ECS, a fully managed container orchestration service, and Amazon EKS, a service which gives customers the flexibility to start, run and scale Kubernetes applications in the AWS cloud and, more recently, on premises. Then we've got our hosting. These are the compute options available for customers to run their containers. Amazon EC2, a service that provides secure, resizable compute capacity in the cloud. And AWS Fargate, a serverless compute engine for containers that works with both Amazon's Elastic Container Service, or ECS, and Amazon Elastic Kubernetes Service, EKS. And they slot squarely into this category. Finally, we've got the image registry category, which is where Amazon ECR, a fully managed container registry that makes it easy to store, manage, share and deploy your containerized images and artifacts anywhere, sits. Now that we've got a better understanding of the container services landscape, Sarah then starts to explain the requirements and constraints that need to be considered as part of any future solution. Sarah's company wants to run containers in a hybrid world. Sarah's company does not want to have separate operating models for cloud and on-premises, as they're not yet all in. The company has made significant capital investments in their data centers, which they need to amortize before they move to the cloud. Sarah's company operates in specific regulated markets and industries which currently dictate that their company own a large part of their infrastructure operations and can't yet use managed services holistically. Finally, Sarah explains that her company needs to have applications deployed close to the data being collected, for example at mine sites, and this is in order to provide higher bandwidth and lower latency to those applications. Having now gathered more information about the needs and requirements of Sarah's company, the AWS Solutions Architect begins to talk through some of the options available which meet Sarah's requirements. We're going to start with Amazon's Elastic Container Service Anywhere. Amazon Elastic Container Service Anywhere, or ECS Anywhere, is a capability that is part of Amazon ECS, which allows customers to easily run and manage container-based applications on premises, including on virtual machines, bare metal servers, and on other customer-managed infrastructure. Amazon ECS customers like Sarah are now able to use ECS on any compute infrastructure, whether in an AWS region, an AWS local zone, an AWS wavelength, an AWS outpost, or in any on-premises environments. They can do this without needing to install or operate container orchestration software themselves. ECS Anywhere supports the use of the same tools and APIs for all container-based applications regardless of operating environment. And this helps Sarah address the need for consistent tooling and governance. ECS Anywhere allows customers to run applications in on-premises environments and easily expand to the cloud when they're ready. This helps Sarah and her business leverage the existing CapEx investments that they've made. It also helps address the compliance requirements, as well as keeping the workloads closer to their data. So all up, this sounds like a pretty good option. However, Sarah's organisation has already made a strategic decision to leverage more open source technologies throughout their projects. Sarah has been asked to explore how Kubernetes could be used as a container orchestration tool for future workloads. Let's now explore what options are available to Sarah and her team in this space. We'll start by looking at EKSD, or EKS distribution. EKSD provides version consistency across Amazon EKS. That's to say, it provides the same installable builds and code of open source Kubernetes that are used by Amazon EKS. Customers can perform reproducible builds with the provided source code, tooling, and documentation. And EKSD includes common major and minor patch versions. This allows customers to use AWS's open source build of Kubernetes anywhere they deploy Kubernetes today. EKSD can also be custom tailored to fit specific use cases using Kubernetes tooling. Now, the open source community maintains support for N-2 of Kubernetes. EKSD offers support for N-3. AWS backports security fixes to align with our version lifecycle policy. This is significant from an operational perspective because, as you may know, Kubernetes releases its minor updates at least 4 times a year, and keeping up with that release cadence is very hard work. Now, Sarah mentions that she saw an announcement at AWS reInvent about something called EKS Anywhere. And going back to the goal of keeping cost containment and management simple, she's keen to understand the differences between EKSD and ECS Anywhere and EKS Anywhere, especially as it relates to operations and management. Let's now look at EKS Anywhere. EKS Anywhere is a deployment option that enables customers to easily create and operate Kubernetes clusters on premises. For EKS-A, or EKS Anywhere deployments, there'll be an independent control plane which is set up using the opinionated EKSD configuration. This means that in a given target site, let's say one of Sarah's company's remote facilities, there'll be a control plane made up of some Kubernetes master nodes and an etcd cluster. This deployment style allows for clusters to operate with full or limited connectivity to the AWS region. And this is an important benefit for sites with potentially unstable connections to the internet. From a management perspective, the goal of EKS Anywhere is not to provide a centralized control plane. EKS Anywhere provides the tooling to provision Kubernetes clusters using EKSD as the distribution. Calico will be used for CNI and pod networking policies. The Linux-based open source BottleRocket operating system will be used for nodes, and in time, the option of using Ubuntu will also be supported. In addition, a number of controllers are going to be packaged with the deploy clusters to support GitOps configuration management, as well as connecting clusters to the Amazon EKS console for visibility of managed Kubernetes objects. Now, having covered a lot of ground with Sarah, the AWS Solutions Architect decides to take a leaf out of Brett's book and attempts to distill this information down into a simple diagram. And this is a fairly simplistic diagram, and it does not cover all of the options, but it does provide a good starting point. In Sarah's case, we know bringing applications closer to data is important. We know that the company wants to use Kubernetes. We know that leveraging existing investments is also important. Now, we didn't ask about connectivity, but let's assume that the sites do need to operate in a limited connectivity mode. That being the case, EKS Anywhere and EKSD in combination might be a good option for Sarah. Naturally, Sarah is keen to learn more about when these options are going to be available and asks when they're coming. Let's start with Amazon's ECS Anywhere. And as a reminder, this is a feature that will enable you to run containers on premises using your own infrastructure. At this stage, ECS Anywhere is coming soon. EKS Distribution, or EKSD, is available today as an open source project. And again, as a reminder, EKSD provides customers with Amazon EKS version, patching and security aligned distribution of Kubernetes, which can be deployed onto customer infrastructure. And finally, EKS Anywhere. This is a service which provides cluster creation and lifecycle using a set of management tools for EKS distribution. And that's coming soon. In summary, during today's session, you've learned that the Snow family has great choices for ingesting and storing data at the edge or for data migration requirements. Outposts provides fully managed services with consistent access to AWS APIs and hardware to give you the freedom to deploy workloads anywhere without needing to reconfigure them. EKS Anywhere, EKS Distribution and ECS Anywhere provide a new set of tools to allow you to support the deployment of applications to locations outside of the AWS region. We've covered a lot of ground today. There's a lot more to learn. And if you are interested in learning more, hop along to some of the training and certification resources on the AWS website. With that, I'd like to thank you for your time today. If you enjoyed this session, please don't forget to leave us some feedback. Thank you.